Hi everyone, one of you sent me this past IGCSE Extended Mathematics Paper 2 question for an explanation on how to solve it, and I figured I'd show it to all of you. Now if you're up for it, go ahead and press pause and try solving this before watching the solution. Either way, let's get started. Here we're told the diagram shows 15 circles in an equilateral triangle. The circles touch each other and the triangle. The radius of each circle is 2.5 centimeters, and we're told that the length of each side of the triangle is a plus b root 3, or a plus b times the square root of 3 centimeters, where a and b are integers. And we need to find the value of a and the value of b. Okay, well effectively, since each of the lengths of this big equilateral triangle are equal to a plus b times the square root of 3, when we're being asked to find the value of a and the value of b, what we really need to try and find here is the length of each side of this equilateral triangle. Okay, well I'll focus on the base of this equilateral triangle. First of all, let me quickly draw the center of the circle to the far left right there. There we go. And hopefully you'll appreciate that if I were to draw this line segment joining that first center to the last one at the base, then the length of this green line segment would be 20 centimeters. And to make that clear, this green line segment would pass through the center of each of the circles at the base of that triangle. And consequently, we can see that we have 3 whole diameters at the middle here. And given the radius of each of the circles is 2.5 centimeters, each of these diameters will be 5 centimeters, so we already have 15, and we have a radius on either end of that green line segment. So that's 15 plus 2.5 plus 2.5, which is 20, so we already have 20 centimeters. To find the total length we have here, though, we still need to add this length as well as this length, which will both be equal given this is an equilateral triangle. And since both of these lengths are equal, we only need to find one of them to then multiply it by 2. And here's how. Let me quickly make a sketch of this last circle here, as well as the corner of the equilateral triangle. So that will look something like this. I have that circle. There we go. And we have the equilateral's corner here, which looks something like this. There we go. And I'll draw the center of this circle right here. And I'll draw the radius right there. Now, on the illustration we have here, we can see that the base of the equilateral triangle here forms a right angle with this radius. So I'll draw a right angle here. And the reason they've drawn this right angle here is to confirm that the base of the triangle here is a tangent to the circle. Furthermore, we're told in the second sentence of this question here that the circles touch each other and the triangle. Now the word touch there is important, since that tells us that the triangle we have here is touching the circle and not intersecting it. And the only way that's possible is if both of these side lengths are tangents to the circle. So I could draw a radius up here as well and another right angle here. And that's important because we've seen from circle theorems that two tangents to a circle that meet at a point outside the circle are equal in length. In other words, if I were to call this point A, this point B, and this point C, then AC and BC would be equal in length. Furthermore, if I call the center of the circle O, the fact that these two sides are tangents to the circle allows us to confirm that OC bisects this angle here, the angle ACB. In other words, this angle has to equal to this angle. But now, going back to the bigger picture here, since we know that this large triangle is an equilateral triangle, we know that each of the interior angles that I'm drawing right now in red must be equal to 60 degrees. And consequently, each of these two equal angles here must equal to half of 60, which is 30. So this is 30 degrees, and this is 30 degrees. Now, using the fact that OB is a radius to the circle and has length 2.5 centimeters, alongside the fact that we now know that this angle here is 30 degrees, we're now in a position to find the length BC that we're after. And just to be clear, this length BC here on our bigger diagram would correspond to the orange line segment I just drew here. So we have BC right there. And to calculate the length BC, we can use our knowledge of right angle triangles. And so if I quickly draw this right angle triangle here, there we go. That would be B with a right angle, O would be up here, and C is here. We know that this interior angle is 30 degrees, and we know that the side length OB is 2.5 centimeters. And now looking at this triangle, the side length BC here is adjacent to this 30 degree angle, and the side length OB, which is 2.5, is opposite. And so using our knowledge of TOA, we can quickly state that tan of 30 degrees must equal to the opposite over the adjacent, which would be 2.5 over BC. And tan of 30 degrees should be known off by heart. Indeed, tan of 30 is equal to 1 over the square root of 3. So this becomes 1 over the square root of 3 is equal to 2.5 over BC. And flipping the left-hand side and the right-hand side upside down, we can rewrite this as the square root of 3 over 1, which is just the square root of 3, is equal to BC over 2.5. And now multiplying both sides of this by 2.5, we have 2.5 times root 3 is equal to BC, which I'll rewrite from left to right as BC equals to 2.5 times the square root of 3. And so we now know the length BC. Finally, going back to the bigger triangle we have here, the total length of the side of this equilateral triangle is therefore 20 centimeters plus 2 times BC, since we have the same length on the other end of the base of the triangle. And so we could write something along the lines of the length is equal to 20 plus 2 times 2.5 times square root of 3. In other words, the length is equal to 20 plus 5 root 3. And that's the length of each of the sides of this equilateral triangle. And so comparing 20 plus 5 root 3 to a plus b root 3, hopefully it's clear that we can quickly state that a equals to 20 and b equals to 5. And that's the final answer. And there we go. That's how to solve this IGCSE Extended Mathematics Paper 2 question.